Are you ready?
Yes.
Good? All right. Hi, everybody. So let's take a second and let's think about your classes that you're currently teaching. And think about the students that are in your classes. Most of them are engineers, chemical engineer, mechanical engineer, something like that. And now I want you to think that they all went away, and your class is now full of English majors and art history majors. God forbid economists and poli-science majors or something like that. Well, now let's make it a little worse. Your class has 10 people, or 100 people, or 1,000 people. How do you deal with that? Well, we're the ones who deal with that. So here's who we are. And we have Eric, myself, Craig, Walker, Maria, Pramod. And basically, we deal with those classes that a lot of engineering faculty don't want to teach, the ones that interact with the rest of the university. And in particular, what we call massively multidisciplinary courses. Okay? So first off, what do we mean by a massively multidisciplinary course? We mean getting the lions and the giraffes to all work together politely, or dinosaurs to wear scarves. But in reality, what we're really talking about is we're talking about the fact that much of what we study and much of what we teach as engineers has importance and impact beyond our disciplines. Right? It affects not only our students, but it also affects the people in the greater world. And so when you start thinking about this, what massively multidisciplinary engineering education, we just coined that term, by the way. I don't know if it's a real term or not, but we'll make like it is, really is all about, it's about how can one extend the learning environment. So move beyond just our majors, but reach a larger and more diverse audience in the process. Now, in doing that, there's a number of interesting aspects to these kinds of courses. First of all, these tend to be courses that have a combination of engineers and non-engineers. Or maybe they're courses that have no engineers, no technical people in it at all, but yet we have to get those technical ideas across. These are going to be courses that have tremendously large ranges of student backgrounds. Okay, so all of a sudden, when you go into your core chemical engineering class, most people are on board with a certain set of mathematics or a certain set of basic chemistry behind them. You might have students that have never seen an equation since their freshman year in high school, or people that are horribly, horribly afraid of math and science. Also, typically these courses are ones that appeal to a wide variety of majors. So just among ourselves here, we have people teaching courses on data analytics, alternative energy, bridges, big data, gaming. All of these things are aspects. They're courses that attract students from across the university. Another interesting aspect to our types of courses, which is not normally involved in a regular technical course, is that we tend to satisfy different university requirements. So all of a sudden, we're getting students taking our course because they need a distribution requirement rather than somebody who's looking to fulfill their major requirements. As I said before, we can pull in large numbers of students. And also, interestingly enough, these types of classes tend to get a significant number of auditors or students who take the class pass-fail, which again, it's something that as engineers we don't typically consider because most of our courses are people who have to take it or they're not going to graduate. Now, if you think about all of this, we can ask, well, what's a classic example of a massively multidisciplinary environment? So I don't know, does anyone have any ideas on this? If not, it's okay. A university.
That's really close.
That's close, right? And you're thinking dysfunction, and I like that. Because here's an example of a massively multidisciplinary environment, right? But we all know how this works or it doesn't work. And hopefully we can do better than this. But interestingly enough, the challenges and opportunities that we see here are the ones that we have to bring into our classes, okay? And so moving on, we could start thinking about some of these challenges. So, Eric?
So when I first offered the course that I developed my innovation for, this was a question I thought the whole class was going to say yes, because I intended to be electrical and computer engineers. I just want to, you guys, if you can get your clickers, tell me if you've ever formally studied MapReduce. I don't mean read a paper about it. I don't mean heard the name Hadoop at a conference. I mean actually sat down and studied it and understand the algorithms behind it. So we got 60. A couple more. 5, 4, 3, 2, 1. So most of the people didn't know it. And this is actually the response I got in my class when I offered it. Because when I walked in and thought I had a bunch of ECE majors, it was actually a bunch of people from all over the college. Somehow environmental scientists and even music engineers decided big data was important to their education. Another class we had that Maria's taught was on statics. So how many people have formally studied statics? Not statistics. Getting the responses quicker. Okay, 5, 4, 3, 2, 1. So more knew this, but still there's a significant portion of the class that didn't. And the reason that we're seeing this diversity of backgrounds is the next question. So we want everyone to tell us what your discipline is. Now, we didn't have space to put everyone. I guess if you're arrow, maybe click B, or don't click because you're mad because we left you out.
I guess G.
Where's computer science?
We kind of lumped it in
I
with
think we're
A.
being lumped into A. That was not my choice. I'm sorry.
Okay, 5, 4, 3, 2, 1. So we have a broad range of people. We tend to have, I guess we've got about a third electrical and computer engineers, a third mechanical, but a wide range of different disciplines. Now take this same graph and add a bunch of additional categories. I mean, within our groups, we had art majors, we had music majors, philosophy majors, people from departments that aren't traditionally engineering or even traditionally science. So this leads to some challenges. The first challenge is that there's a diversity in the learning styles and the comfort levels that the students have with certain technical concepts. They may not have encountered some of the things that they're running into in the class, but the class may still be important. So how do we reach those students? How do we assess students across different backgrounds? Walker, one of his problems was, you have art students and computer science students in a gaming class. They're obviously not completing the exact same assignment, so how do you give a fair grade? In addition, there may be heterogeneous expectations from the students and different departmental and college grading practices. At my university, in our department only, a D is a failing grade. And the rest of the university, a D is bad, but it won't fail you or fail to satisfy a prereq. There's also the potential for a significant percentage of auditors or people taking the class pass-fail, which will skew your ability to assess. People who are auditing or who are taking the class pass-fail might not put as much effort into an assignment, so then you get back and you see an average of a C for a class where you thought everyone was getting it. How do you know which portion was auditors and pass-fail? Not all universities give that out. In fact, between us, we had universities that would tell you that information, that wouldn't tell you, or that you had to really hammer on some doors and demand the information before they would share it. It can affect student contribution levels and their willingness to put the time in they need to. And then there's also the issue of scaling. So what's the effect of increasing class sizes like this on learning outcomes? Obviously, we're going to have a lot of students who need more attention, so there's a lot of logistics that go into creating these. And how do we balance technical rigor while still allowing creativity and open-endedness in these courses? So Pramod will tell us a bit about how we're solving these.
So these challenges are enormous, and when you put things in perspective, when we started talking about what do we do to address these challenges, we realized that there was no one way of doing this. And at least the core group that we have here, we did not really find that we were commonly overlapping on certain things. So we decided to celebrate our heterogeneity here. We decided to understand what each of us was doing, and we kind of scratched the surface here. For a class like mine, where I have up to 1,000, 1,100 students, there is absolutely no way you can have inconsistency. You absolutely have to have consistent messaging. You need to be absolutely clear about how the communication takes place. We give extremely clear rubrics. These are released well before the time of the assignments being released. The expectations are made very clear. There's a single email address. They don't email the professor. They don't email the TAs. There's a single email address. It's like a one-stop shop, customer service kind of a practice. And so, I personally worked with the bunch of management consultants who helped us put this in some sort of a management practice framework, and that allowed me to run this class in a steady state now. We tried to flip the classrooms because that's something that we have been talking about. We recently, my research group published a paper where, you can flip the classroom, and computation and data science and all these things are great, but has someone measured the learning outcomes and what is the statistical significance of these kind of pedagogies? What we found, one of the papers that was presented by one of my grad students just last week at the FIE, was that when you run a classic sage on the stage, teacher-centered approach, we found that the distribution gets polarized. There's a lot of A's and there's a lot of C's and D's, but we found hardly any B's. On the other hand, you flip the classroom, you allow engagement, you allow scaffolding, and you see a really nice sort of unimodal, smooth distribution of grades where there's a lot of B's, less number of A's. And so you ask yourself, what do you really want to do? You want to concentrate on people that are going to get A's through your teacher-centered approaches, or do you want to bring that mass of C's and D's and sort of move them towards the B's? So these kind of insights come out every now and then, and they kind of baffle you. We have professors who teach environmental impacts and environmental engineering. Part of the pedagogy involves understanding the impact of human activities and using the campus as a classroom. So you go around the campus and you kind of figure out what's going on and how things are being impacted. And of course, integrating outreach with education, going in front of people, going in front of, trying to make other people understand what you're doing is a very integral part of these kind of pedagogical approaches.
All right, so you're going to pass this over to me? Fair enough. So that's one way that we can sort of approach these things. Another thing to keep in mind is if you know information about your heterogeneity, it helps a lot. So several of us will take surveys at the beginning of the course to just figure out who the hell is in our course, right? And if you do that, if you know a lot about the demographics, then you can actually start tailoring bits and parts of your courses to those individuals, depending upon who they are. So one solution, depending, in one course that we had, was if you have some students who are weaker in background, but they could be brought up to speed, then one of the things that you're going to do is you're going to front load the people in your class who are going to be experts, right? So if you're having presentations, they're the people who are doing stuff early on, and then they can act as a form of mentor to perhaps the students who are weaker in your class or have less background. If you're in a class like mine where you have people coming from radically different disciplines and they're contributing very different things to the courses, then the things that you might want to do there is to have your infrastructure not just to be bland TAs that are all the same, but make sure that your course staff are content experts so that you can have each one of them giving individualized instruction to the different people who are in your class. Now I'll pass it off to you.
My voice is a little softer than Walker's, so I'm going to use the microphone. So what I've found, and what we've all found that works well, is experiential learning, and I think we've heard about that today, and using real examples. So in my class where I teach about bridges, I teach through real people, Roebling and the Brooklyn Bridge and the Eiffel and the Eiffel Tower. And the other thing I find works really well is bringing kind of modern ideas and modern movies. So last time this Batman movie, Dark Knight Rises, I think it's called, came out, and my TAs alerted me to the fact that they got the bridge explosions all wrong. So I thought this was a great opportunity to show this to the class and have them tell me why is this wrong. So I had a lecture coming up on Manhattan bridges, and not only are the explosions and the consequences of the explosions all wrong, but they put bridges in there that don't even exist. So I'll show you this 10-second clip of the movie, if I can get it to go. Nope, hold on. Oh, here we go. All right, so if you look, it's going to explode at midspan, and there's no way that bridge would remain standing if you knew anything through my class, right? And on the west side of Manhattan, this is the lower west side, those bridges don't exist. We have tunnels there, we don't have bridges there, but it's the same kind of explosion that doesn't collapse the bridges. So Hollywood got it completely wrong. And so the students like infusing this kind of things into the classroom. So we talked about our challenges, but we also have opportunities. So as Craig mentioned in the beginning, we're teaching humanities students. And in my experiences, I've had several students switch majors. So they started off in the humanities, and if they're freshmen that come in with AP, it's not too late to then bring them into engineering if that's their interest. And for this course on bridges, usually the confusion is they're thinking they want to be architects, and by the end of the course they realize, no, I want to be a structural engineer. But the best student we have in our class right now in civil engineering started out as a comparative literature major who took this class as a freshman and now switched into engineering and is one of our best students. So we have I have seen many of these examples of people coming in. But even if they don't come in, I don't think that's our main goal. Our main goal is to educate the broader public about engineering. If you go on to be a politician, it's really good that you know about energy and infrastructure, data analysis. So our real goal is to educate a broader audience, not only the knowledge, but skill sets that they can use. We encourage this cross-disciplinary interaction, again, a real-world experience, and provide a broad education necessary to understand the impact of these engineering solutions in a global, economic, environmental, and societal context. And that's it? No, we won't go to this because we don't have time. So we'll stop here and answer any questions.
You have one behind you.
Tim Bigelow, Iowa State. I guess the first question I have is, I tried to create a course that would bring in people not in engineering. It failed. None of them ever signed up. What did I do wrong?
Well, I think an interesting point is not all of us set out to create that kind of force. So what did we do right? I think it's a tough question to answer, right? The biggest thing I think is to survey the interest on campus, talk to some of the departments, find out what they want to offer. Actually, after offering this class for a semester, I was approached by the business school who is interested in incorporating the class into their actual curriculum. And we didn't have any business majors the first time. I think we have one now. So it's fulfilling a need for the other groups. Maybe talk to the science or some of the different science and engineering and humanities majors. We talked a lot with people at the hackathon, which had a lot of artists as well as other things, and turned out that they had an interest in big data. And I don't know if anyone else has other things.
I'll add that. So I had an experience like that when I first started teaching, where I wanted to offer material scientists, I wanted to offer a course on quantum mechanics and material science. And I tried to offer that to engineers. I had no one to sign up because engineers are utterly afraid of quantum mechanics. And I tried to put that into the description. And I think the lesson learned there, and it applies to the non-majors, the non-engineers, is, the words that we use in our descriptions for the course are really key words that throw people away really quickly. They see the words that they're afraid of. Technology, science, math, And so the first thing is to very carefully craft the message that you put out there. The second thing that I think does work effectively is linking up with some other departments. So in some cases, if you can either get another department on board or cross-list or something, finding interdisciplinary centers to offer your courses from. So for instance, at Princeton, we have a number of interdisciplinary centers where one can, an environmental institute. And so for instance, if I'm going to teach a course on alternative energy, having that be cross-listed in that department rather than just listed as a mechanical engineering course tends to get people over that fear of taking an engineering class.
Thank you. We'll move on to design.
Oh, you have a question back there?
So we're behind, so